I've been off enjoying my summer, but I've also built version 3 of my Portadeck. I've been thinking of just calling it a lap dock. I've seen that name around. Maybe that makes more sense, but let me know what you think and what I should call this thing. So this design has a large number of changes from V2. I mentioned that V2 was a lot of smoke and mirrors. This is much more functional, and I've been using it for months. I've been working pretty much daily on this computer. It is now self-hosting, i.e. I am designing the next iteration on this computer. Let's talk about a few of the pros and cons. To talk about ergonomics real quick, I'm a big fan of the keyboard forward design here. Most laptops have a trackpad that is below the keyboard trackpad, meaning that the keyboard is at the far end up here. So I enjoy having the keyboard closer. I feel like I'm reaching less. I also like the gradient here where I can rest my hands at a comfortable angle instead of the hard edge of most laptops. I've also found that it's quite comfortable for me to use at the desk or sitting on my couch. Since the lap dock is essentially a client separate from the actual computer, it remains cool as a cucumber on my lap. This is probably my favorite part of the system and one of the main reasons I chose the design I did. It is also quite versatile. Since it's not specific to my computer, I've used it with other hardware as well. One of the larger redesigns from V2 is that this is a fully printed design. V2 used an aluminum bottom plate underneath this, laptop hinges, these little things right here, and smaller plates glued to the hinges. I initially felt that laptop hinges would be a better option. This ended up being a lot of work as the parts are very small, the tolerance is very tight, and my CAD skills still growing. These hinges work pretty well. They are more than strong enough to hold the monitor in position. When I switched over to work on the camera mount, I iterated heavily on different fixation hinges, and you can see that in other videos. I was really focused on this use case. When I built a design, though, that was configurable and strong enough for the hinges here, I changed the main clamshell hinges over to use it. So a couple negatives here. Due to the printing orientation, the hinge leaves are not as strong as I would have liked. The alignment of the printing means that the layer lines are in the wrong orientation. Because of this, I over-tightened and cracked the right one here. But surprisingly, it is still very strong even with this issue and has not stopped me from using the laptop daily. The second problem I've had is that it loosens over time. Because of this, I've had to retighten it a couple times. My guess is that this is related to a bit of settling in as the conical hinge pins work back and forth. So with V3, I built a monitor enclosure that fully encircles it. The monitor is removable by removing a couple screws here and here. And the lip of the monitor means it no longer hits the keyboard when it closes. And then naturally now it's making that noise. Oh yeah. The camera mount has been absolutely solid, and just having the ability to adjust it back and forth is fantastic. I'm quite happy with this part of the design. So using epoxy to glue the pieces together worked very well. It takes much longer to cure, but it is worth it. It is absolutely rigid and proves that I don't need an aluminum plate or additional supports. A lot of this process for me has been figuring out where 3D printing has its strengths figuratively and literally. This is one area that surprised me that it was so strong. So what are the improvements for the next design? Well, one mistake I made was in the recess of the speaker tray. It is unfortunately too shallow and the top hits the monitor when closing the laptop. It turns out my placeholder model is not thick enough. I think I needed to take into account the rubber feet. Another improvement for V4 is to better match the dimensions between the bottom and the top. One of the problems I've been running into with Onshape is that because I'm frequently iterating on parts, I have to rebuild the assembly, which is additional work. For example, if I split a part into two parts for 3D printing purposes, I need to rebuild that assembly, which I'm being lazy about. If anyone has any Onshape tips on how I can better handle this workflow, let me know. So designing moving parts is something that I have struggled with, specifically the hinge. I have been working on changing the position of the hinges to be lower instead of on top of the laptop. This looks cleaner and more modern. While my conical hinge design worked, the limitations of 3D printing are very apparent. Designing small 3D parts that need to be very strong to hold up the monitor and provide adjustable torque has been difficult. It has also been difficult to create parts that fit well together. Using supports means that getting a clean fit can be problematic, and not using supports means only certain orientations are possible, causing the part to not necessarily be strong enough due to a layer line orientation. I think I'm going to explore using pre-made hinges, but instead of laptop hinges, which involve a lot of engineering and concealment, I'm going to use adjustable shelf hinges. This may look a bit less than ideal, but it's something I'm willing to live with, at least for now. I bought some 180-degree adapters for USB-C and micro HDMI to stop the cables from jutting out the side. This initially seemed like a great thing to do, but after a while, this started causing damage to the HDMI port. I did not realize how much stress this was putting on the port, and it was causing the monitor to blip off occasionally. I have resorted to using tape to reduce the amount of pressure on the cables. I'll have to design some kind of strain relief for the monitor for V4. I've also been looking into making a power bank that I can connect to my tower. My design uses a DC ATX power converter board, like this right here. These allow for the use of an external power brick or other DC power source, such as a battery, to power the computer. The ones I have take roughly 12 volts in and regulate that to the expected voltages out, which for ATX means 3.3, 5, and 12 for various purposes. I've also purchased a new board from Minibox, the same people who make the Pico power board, called the M2 ATX, which allows for a much wider range of power. This will allow me to use higher and lower power outputs. Most laptop bricks are 19.5 volts. Why 19.5, you may ask? Because this keeps laptops in the limited power source range, making certification cheaper and easier. So the M2 ATX will allow me to increase the voltage range and use laptop power bricks. Currently, I'm using this Schnitt Power, no, I'm not making that name up, power brick that outputs 120 watts. That's 12 volts at 10 amps. This has worked surprisingly well for me for months. It's not bad, but at 12 volts, my options are very limited, not only with power bricks, but with batteries. By going higher in voltage, I can also get more power at the same amperage. So here's a Slim Q power brick. This is what's known as a GaN charger, or gallium nitride charger. While most electronics components are built out of copper, by building a power brick using gallium nitride, you can convert more power more efficiently and with less heat. The trade-off here is cost. A GaN charger will cost you about 4 times the price. This smaller brick, though, delivers 24 amps and 20 volts, 240 watts, literally double that of the Schnitt power brick. It also has circuitry to provide USB-C power as well. So my portable monitor draws about 12 to 13 watts of power at 60% brightness. If I increase the brightness or use a monitor with higher brightness, the power tips over and the monitor browns out and restarts. Now this is an issue not with the monitor, it's an issue with the power output from the computer. High power output over USB is something I would like to have more of, but desktop motherboards don't provide a lot of USB-C power output. And so I will be adding separate circuitry that will provide more power. This will also free up my USB-C port for other things. For more info, check out my previous video on these boards. I'm currently testing other boards that I can add to provide additional USB-C PD ports. And again, SlimQ, the maker of this charger here, makes a really cool little small USB-C board with boost buck functionality. Look for a video on this soon. I bought a 12-volt lithium iron phosphate battery that I've been toying with as well. I've been using this to run my portable monitor, and it will run the monitor for around 7 to 8 hours without issue. I'm pretty sure that I can probably run this computer off this battery for a good period of time. As long as I don't do any heavy computing, the monitor is roughly 15 watts tops, the computer is roughly 30 to 45 watts average, the battery is 128 watt hours. I can always add more, go big. But for this, I think I can likely get 2 hours tops out of it, which is pretty good. To sum up the power upgrades, I want to upgrade the power board to provide a wider range of voltages. I want to upgrade my power brick to a smaller GAN charger at a traditional laptop voltage. I want to add additional USB-C power delivery ports. And then likely I can hook up to a battery without issue. And to sum up the upgrades for the V4 clamshell and case design, I want to redesign the computer case to fit the new power system. I want to move these hinges to be below and behind the clamshell instead of on top of it. I want to use pre-made adjustable torque hinges. And I also want to fix this speaker recess to be a bit deeper. And I want to add strain relief to the monitor cables. It looks like I have a lot of work still to do on this new version. It has been a very interesting process, and I'm enjoying it. If you have any thoughts or ideas for improving the design, I'd love to hear them. Thanks for watching, and I'll catch you on the flip side.